To understand the mystery of existence, we must journey into the nature of nothing. But beware, what physics calls nothing may be the most misleading word in the cosmos. When physicists speak of the vacuum or empty space, they don't mean an absolute void. They're referring to the lowest possible energy state of quantum fields. And this so-called vacuum is far from empty. In fact, it's bursting with invisible activity. Welcome to the quantum vacuum, a restless sea of fluctuation, ruled by the laws of quantum mechanics. In this bizarre realm, virtual particles constantly pop in and out of existence. These fleeting pairs of matter and antimatter borrow energy from the vacuum, live for just a split second, and then vanish again. It's like the universe is whispering to itself at every point in space and time. This isn't science fiction, it's measurable. One of the clearest demonstrations of the quantum vacuum in action is the Casimir effect. When two uncharged metal plates are placed extremely close to each other, mere nanometers apart, they begin to attract each other. Why? Because the sea of virtual particles between the plates is more restricted than the space outside, creating a tiny pressure difference. The result? The plates push together. From nothing, a force. This proves that even the emptiest region of space is teeming with energy. It's not a void, it's a quantum field playground. But what does this have to do with the origin of the universe? To begin answering that, we must acknowledge that the Big Bang theory describes not the creation of the universe from nothing, but its evolution from an extremely hot and dense state. What came before, or whether before even makes sense, is still a deep unknown. Some physicists propose that the universe emerged from a quantum fluctuation in this vacuum. In other words, the universe may have begun not from true nothingness, but from a quantum something that was nearly nothing, but not quite. One popular idea is the concept of false vacuum decay. Imagine the quantum vacuum as a landscape of hills and valleys, with different energy levels. If our universe was trapped in a false vacuum, a temporary low-energy state, it could have spontaneously decayed into a lower, more stable vacuum. This decay might have unleashed a bubble of space that rapidly expanded, triggering inflation and giving rise to our entire cosmos. This kind of idea blurs the line between physics and philosophy. It raises deep questions about causality, existence, and beginnings. So, what is a quantum vacuum, really? In quantum field theory, every type of particle corresponds to a field that fills all of space. An electron is a ripple in the electron field. A photon is a ripple in the electromagnetic field. And the vacuum is what you get when all those fields are in their lowest energy configuration. No ripples, no waves. But because of the uncertainty principle, even these calm seas are never truly still. The vacuum seethes with zero-point energy, the lowest energy that a quantum system can have. It cannot be removed. And this zero-point energy could have enormous implications, not only for the birth of the universe, but for its ultimate fate. One of the biggest mysteries in cosmology is dark energy, the force that's accelerating the expansion of the universe. It's as if space itself has an energy that pushes galaxies apart. Some theorists believe that this dark energy might be connected to the energy of the quantum vacuum. If that's true, then the nothing that fills space is actually everything. It shapes the cosmos. It might have birthed the cosmos, and one day it might end it. Now think about this. If the vacuum isn't empty, then perhaps nothingness is simply a limit of our imagination, a word we created to describe the absence of something, when in truth absence doesn't exist. There is always something, fields, fluctuations, potentials, lurking beneath the surface. The implications go beyond physics. They touch on metaphysics and meaning. Because if existence can arise spontaneously from a seething field of near-nothingness, then perhaps creation isn't as rare or as divine as we once believed. Maybe universes are natural consequences of physical laws we barely understand. Maybe they're being born all the time, in pockets of vacuum, in other dimensions, in other realities. Maybe we are not the miracle. Maybe existence itself is the default. But for now, we continue exploring, peering into the vacuum with powerful instruments, teasing out its secrets with ever more refined theories. And every time we do, we come closer to understanding the ultimate mystery: how a universe could arise, evolve, and become aware of itself. In the next episode of Infinity Beyond, we'll explore the cosmic inflation that followed the Big Bang, an explosive moment of expansion that set the stage for galaxies, stars, and life. Stay curious, stay inspired, because even in nothing, there's a universe waiting to be discovered.